derived from a thermo mean heat. Gravi is derived from a gravity mean related to mass change, and metric mean measurement. So thermogravimetry is a technique in which we measure the change in a mass as the temperature is changed or as a function of a temperature. It is represented as TGA. T stand for thermo, G for gravity and gravimetry, and A stand for analysis. So just look at the definition of TGA. It is a technique in which mass of a sample is recorded as a function of temperature or time. It's mean that now we are going to increase the temperature with the passage of time. We have to measure the how much the mass of a substance is going to change. Got it? So next point is that this phenomena is used for qualitative as well as quantitative analysis. So by using a thermogravimetric technique, we can measure the quality. Quality is actually term referred to the identification of component or constituent of a substance. Got it? So let's say for example I want to assess the composition of a blanket, either which substances are the present in the blanket. So we have to just only identify the substance is called a qualitative, while the how much the substance is present in the sample is identified by using the term quantitative. So qualitative is represent the identification, and quantitative is related to the term quantity. Thermogravimetric analysis is only applicable for a solid substance. Let's say for example we can perform a thermogravimetric analysis only for a solid substances. We cannot perform it for a liquid, gases, plasma, or a Bose-Einsteinium condensate or any other state of a matter. We just only have to perform against a solid state. So let's discuss about the thermogravimetry. Tell us about the thermal stability. That is the most important short question according to the paper point of view. Thermal stability of the substance or the compound is predicted by using thermogravimetry. Oxidative stability of a material can be predicted by using thermogravimetry. Composition of a multiple component system is actually a qualitative analysis. It means the composition of a multi-component system. Estimate the lifetime of a product. Let's say for example if I'm going to heat up a substance that is a X, it will be converted into the Y, and how much time Y will be survive, and upon which temperature it will be converted into Z. So it is the actual mean of this sentence. Decomposition and the kinetics of a material. Kinetics is referred to the speed of a reaction, how much time it's required to be complete. The moisture or the volatile component of the mixture. By using a thermogravimetric analysis we may determine either the water as a water crystallization is present in the compound or not, or any moisture like a volatile component like NH3. Sometime in the case of COCl3, cobalt trichloride, ammonia is present and it is released in the form of gaseous phase. So this is the general example of the representation. I just took assume or suppose values. So to just deliver the concept regarding the thermogravimetric analysis. Let's take an example. I took a china dish in which I took sand and water. So the total mass of the sand and the water is 100 gram when the room temperature was 25 degrees centigrade. Now I took a tripod stand and Bunsen burner. With the help of a Bunsen burner, now I am going to increase the temperature of this mixture. So with the passage of time, when the temperature is gradually increasing from 25 to 35 degrees centigrade, the mass of this mixture is reduced from 100 to 95 gram. So when the temperature is further increased from 30 to 50 degrees centigrade, then the mass of the substance is decreases from 95 to 85. Mean the 10 gram of mass is lost. Why this mass is going to be decreased? Because as we know that the water also have a weight. So by increasing the temperature, the water is going to be shifted from a liquid state into the gaseous state, this phenomena is known as a evaporation. So as the temperature is gradually going to increase, now the mass of the substance is gradually going to decrease, but this will be happen in the case of the substance where the evaporation is going to be take place. So it is a here it is also a most important short question, that is the reasoning for decreasing the mass of a substance. What are the reason or behind why the mass of substance is decreasing? The first reason is the evaporation, second is the decomposition, desorption, adsorption and water of crystallization are all the 5 reasons which are the responsible for decreasing the mass of a substance. First one is the evaporation. As we have seen in our previous example, that when we are going to increase the temperature of this mixture, the liquid water is going to change from a liquid state into the gaseous state. This phenomenon is known as a evaporation. Decomposition, when a salt like calcium carbonate CaCO3 is decomposed, it will be form a calcium oxide and the carbon dioxide. As we know that the carbon dioxide is a gas, it will leave this mixture. Similar case with this, we have iron hydroxide, and now I'm going to heat up the iron hydroxide. It will be changed into ferric oxide and the vaporous water molecule, and this water molecule will leave the container because they are present in the form of gas. Silver bromide, now by using the light, when the light will be the fall on the silver bromide, it will be converted into bromine gas, and bromine gas will leave the container. So similar case with the potassium perchlorate, it will be changed to potassium chloride and the oxygen gas. Desorption is actually when we are using a Wilkinson catalyst or other catalyst heterogeneous analysis, as we know that the nose surface is 100% smooth, because there are the small pores which are the present in the surface of a solid substance. Although we have a whiteboard or a glassy surface of any substance, it have a minute pores in it, and between these minute pores the gas molecule will be present. So the escaping of the gas molecule when we are going to increase the temperature will also responsible for decreasing the mass of substance. And the next in the adsorption, the similar case as we have discussed in our BSc or MSc syllabus in the case of the Wilkinson catalyst. Water of crystallization. So first of all I have to define the water of crystallization. The amount of water which is responsible to maintain the structure of a water molecule is called to maintain the structure of. So first of all I have to define what is meant by the water of crystallization. So water of crystallization is actually the water which is necessary to maintain the structure of a crystal is called a water of crystallization. Let's say for example the copper sulfate have 5 water molecules that are which are the responsible to maintain the structure of the copper molecule, copper sulfate. Similar case with the calcium sulfate CaSO4.2H2O. These 2H2O molecule are the responsible for to maintain the structure of this calcium sulfate molecule. So the COCl3 cobalt trichloride, they have also 5 to 6 water molecule. So these water molecule will maintain the structure of the crystal. Now look at the basic principle of the thermogravimetry. Thermogravimetry have the principle reactant is present in the solid form will be heat up to change into the product in the solid form and the gas. Reactant in the solid form we combine with the gaseous phase while we are going to heat. Now the question is that how it is possible that you are going to heat up a gas with the solid substance. Actually we have to take a closed system in which the gas will never leave the system, and we have to heat up this reactant mixture and it will be converted into product. Next thing is that how the mass is lost due to the gas. Like calcium carbonate is going to be heat up at the decomposition temperature, it will be changed into the calcium oxide and the carbon dioxide. So calcium oxide is present in the solid form and the carbon dioxide is present in the gaseous form. So carbon dioxide will escape the system. Now the mass of the calcium carbonate for example at the initial state was 5 gram, but after the decomposition its weight it decreases to the 2 gram. So it means that the 3 gram of the carbon dioxide which was the present in the substance in the calcium carbonate mixture is escaped by heating the calcium carbonate, and the calcium perchlorate KClO3 will be changed into the KCl and oxygen molecule. So oxygen is also present in the form of a gas, it will leave the container. Loss of water due to the water crystallization. This is actually you have already seen in your previous classes that the calcium, when we are going to write a copper sulfate, here we also see the 5 water molecule. Now we are going to increase the temperature and heat up this reaction mixture. It will be converted into a copper sulfate monohydrate, and the 4 water molecule will be leave the container. And the loss of water due to the constituents. Constituents mean that there is a possible substances which are the present in our compound when we are just only increase the temperature. When we have to increase the temperature of the molecule, the constituent will arrange themselves in a such a way that they will combine together. When they are going to combine together, and they will be converted into the iron oxide and the water molecule, and decrease the mass of overall the product. When we have performed our task, when we have performed thermogravimetric analysis, the result are present in the form of this graph. This graph is known as the thermograph. So first of all, we have to understand the abscissa or x-axis of this graph is represent the temperature, and the y-axis of the graph represent the change in the mass. As I am going to move upward, the mass is going to increase, and I am going to move downward, the mass is decrease. So similar case, as I am moving toward the right side, the mass is going to, temperature is going to increase, and I am going to move toward the left, the temperature will be decreased. So always in the thermogravimetric analysis, always there is a change or decrease in the mass of a substance. Got it? So here is a step like arrangement in the graph. It will tell about this horizontal portion of the stair will tell us there is no change in the mass, and this vertex or vertical portion will tell us the loss of a mass. Here you may note that when we have a copper sulfate pentahydrate is heated at the 100 degrees centigrade, it will be converted to the copper sulfate trihydrate, and the 2 water molecule will be released from here. And the similar case, and the temperature is going to increase and the mass will be decreased, and finally it will be changed into the cuprous oxide, and mass will further decrease. The thermograph for this reaction is represented here. So thank you so much. You may note all these slides, take a screenshot from these slides, and make your own notes. The verbally I have explained the much more things for your conveniency. So please note these things on your register, on your notebook.